When accepting configuration for your application from external sources, it's a good practice to ensure that any configuration values meet your expectations. In this demo, we'll begin by applying some simple validation using data attributes on the properties of options classes. We'll also explore how and when validation is applied and look at a technique to ensure that options are fully validated at startup. Let's apply some validation to the homepage configuration. As a first stage, we'll ensure that the forecast section title always has a configured value. We can add a required attribute to the property to apply this rule. This requires that we include a using directive to the system.componentModel.dataAnnotations namespace. The next step is to configure our options so that the framework knows how to apply the validation rule. Inside the program file, we'll replace the existing call to configure that binds the configuration section to our homepage configuration class. For now, I'm going to comment it out. Instead, we'll use an approach which lets us control the options registration more precisely. We'll call add options on the iService collection, passing our homepage configuration type as the generic argument. This returns an options builder, to which we can chain additional methods that control the options class that we're registering. The first important method is bind. This takes an iConfiguration object from which to bind the properties of the options class. We'll pass in the features:homepage section. This is just a slightly longer hand way than using configure to register the options class and bind it, but we can call other methods when building this options instance. We'll call the method validateDataAnnotations. This tells the options feature that we want any validation annotations on this options class to take effect. I'll now run the application to see what effect this has had. The homepage loads without any errors, and that's because our current configuration is still valid. So let's change that. I'll comment out this line in the appsettings.json file, which sets the forecast section title. Now, if I run the application again, an exception is thrown and we're shown the developer exception page. The middleware has caught an unhandled options validation exception. The fact that the required forecast section title is no longer being configured has been validated. If we review the stack trace, we can see that it was the call to the options.value property which triggered the exception to be thrown. You may already see why that's slightly problematic. I'll stop the application and use the launchSettings.json file to force it to load a different page by default when the application launches. I'll set the launch URL to the contact page and start the application again. Once the application has started, the contact page loads. If I navigate to the home page, boom! The options validation exception is now thrown. This is a little unfortunate. We only get a validation failure when the options instance is first accessed. In this case, when the constructor of the index model accesses the value property on the iOptions snapshot instance. In many cases, if our options classes are invalid, we may not want the application to start at all. Having the application blow up randomly at runtime is often not desired. It would be better to fail fast and log an error rather than allowing users to reach some pages which will simply fail. To handle this validation exception and avoid the page blowing up, we could wrap all calls which access the value property inside a try-catch block. That's likely to get missed somewhere, and even then it's probable that the page won't function without the required and valid configuration values. A solution is to force validation of the options classes when the application starts up. Returning to our add options code, we can chain a call to validateOnStart to configure validation to occur when the application first loads. With this one small change, if I rerun the application, an exception is thrown immediately at the point when app.run is invoked. If we view the detail and expand the failures collection, the first and only failure is from the validation of the forecast section title on the homepage configuration. Failing early for required configuration can be helpful because it prevents the application from starting until all necessary configuration values are defined. With data annotations, we can even customize the error message for such validation failures. When adding the required attribute to the property, we can include an error message that is more descriptive and specific to our application. After making this change, a validation exception still occurs when I rerun the application, but this time the message reflects the value we specified on the attribute. Hopefully, you're already thinking about places to apply validation in your applications. I'm sure you may also be thinking about more complex scenarios you have for validation in those applications. In the following clip, we'll tackle two advanced approaches which go beyond basic annotations and let us further control options validation. Before moving on, I'll make sure to reset the launch settings.json file so that the homepage is loaded when the browser launches. This demo will look at two more advanced techniques to define validation for your options classes. We'll begin by defining a validation action that applies more complex conditional validation logic for an options class. Next, I'll introduce an advanced technique that you can use to apply validation that relies on other services within your application by implementing iValidate options. So far, we've applied a basic validation rule for a required property on the homepage configuration using a data annotations attribute. We'll now remove the attribute and define our validation rule in a different way. We'll amend the options builder so that instead of attempting validation using data annotations, it accepts a function that will run to validate the properties on the options class. We'll call the validate method to register this function. The signature of the function accepts a homepage configuration instance and returns a boolean. The boolean indicates whether the options class has valid properties or not. We can either pass a method with the appropriate signature or, as we'll do here, define an anonymous function. Previously, we expected the forecast section title always to be required, but strictly speaking, it's only required if the weather forecast is enabled. We can check against multiple conditions within the function and then return the appropriate validation outcome. If the forecast is enabled and the title is null or empty, then we'll return false, which indicates it isn't valid. Otherwise, we'll return true. This code can be simplified to a conditional expression using the Visual Studio tooling. The validate method has an overload which also accepts a failure message. We'll provide a more descriptive error message for this validation check. If I run the application, the validation should still fail because the forecast is enabled and the title is missing. Indeed, the options validation exception is thrown and the failure message reflects our custom validation error. Let's stop debugging and return to the appsettings.json file. If we amend the settings, configuring the value for enable weather forecast as false, we'll try rerunning the application. This time it loads without an error since the title is not required when the forecast is not enabled on the homepage. This approach to validation works well when you only need to inspect properties on the options class that's being validated. Some of you are now probably asking, what if I need to use a service or a different options class when performing my validation? Well, don't worry, Microsoft have you covered. The solution already includes a class called Homepage Configuration Validation. We will use this final approach to provide some more complex validation logic with additional dependencies. A great thing about this approach is that these validation classes support regular dependency injection. The constructor accepts 3 dependencies. The first 2 are iOptions instances for other options classes, and this can be really useful as my validation rules can now also be conditional based on configuration from other options classes. As a third dependency, I've also injected an iProfanity checker, a service registered with the dependency injection container. We'll now complete this class. First, we'll have it implement an interface called iValidate options. This is a generic interface and accepts the options type which is being validated. I'll ask Visual Studio to implement this interface to scaffold the validate method that it defines. The validate method takes 2 parameters, a name, which we'll ignore for now, and a home page configuration instance. This method returns a validate options result. Inside this method, we can define validation logic, consuming the injected services where necessary. I'll paste in some validation code and we can step through it. The first condition performs the same logic we'd previously defined within the validate method on the options builder, but with one addition. First, it uses the application-wide weather forecasting configuration options instance, which was injected via dependency injection. Only if the weather forecast is enabled globally, and then, if it's enabled for the homepage, will the code ensure that the title is present. The second condition applies profanity checking when this feature is enabled in the content configuration. The forecast section title is passed to the contains profanity method, which will identify if any prohibited words have been included in the configured title. In either of these conditions, if the validation fails, I use a factory method on validate options result to create a failure instance. This method accepts a validation error message. If both validation conditions succeed and the options instance is considered valid, then I'll access the static success field on the validate options result to return a successful validation result. Before I run this code, I'm going to adjust the configuration so that we can see the validation in action. I'll ensure that the forecast feature is now enabled and update the configured value for the title to include a blocked profanity word. I'll run the application, expecting validation to fail and an exception to be thrown at startup. But the validation doesn't fail, and the application is not prevented from running, so what have I missed? Well, in order for the validation to be executed, we need to register our options validation class with the dependency injection container. Before we do that, I'll comment out this validate function that we no longer need because we now have more advanced options validation defined. To perform validation, the framework will scan for all instances of iValidate options and call them in turn. Because multiple instances may be added to the container, we'll use the try add enumerable extension method on the iService collection to register our options validation implementation. This method takes a service descriptor, which we can provide. We'll register a singleton service descriptor of the iValidate options service type with our class as the implementation. If you want to learn more about service descriptors and these less common service collection methods, you can find that and more in my course, Dependency Injection in ASP.NET Course 6. With the validator registered, I'll try running the application once again. This time, an exception is thrown at startup. In the details, we can see that the failure message indicates that the validation detected a blocked profanity word and therefore the validation failed. Using this approach, we can define complex validation conditions for our configuration within our application. Before we move on, let's remember to remove the profanity word from the forecast section title in our configuration.